Hello, everyone. Welcome to today's webinar. So today we're going to be talking about a brand new feature we've just released in version 7 of OpenNebula. So this is our AI-powered DRS functionality. For those of you who've been using VMware or platforms like that who have had DRS for many years, it'll be quite familiar. But I'll be joined by my colleague Marco, who will be doing some slides around the architecture and setup of it, and also a demo. So this I will kick off today's session with a bit of a market overview as to why we've done this and the kind of things we've been working on over the last 6-9 months or so. And there'll also be a chance for a Q&A at the end. So we've already been sent a bunch of questions from folks who signed up to the webinar, which we'll go through. And if anyone has any questions while we're going through the webinar today, please feel free to post them in the chat and we'll do our best to get round to them. So I'll kick off with a little bit of a really quick introduction to OpenNebula. So I know many folks here today probably know who we are, but we're an open source infrastructure as a service solution, which was created around 18 years ago or so now. Got a really large community, and the enterprise version of OpenNebula kind of kicked off around 15 years ago, where the OpenNebula Systems, which is the company behind the OpenNebula software, offer kind of like the enterprise edition version and support and services on top. We're headquartered in Madrid in Spain. We've also got offices all over other areas of Europe, in Brussels and Brno, and also in the US as well, in near Boston. And we have a really large, customer base here. There's over 5,000 clouds running OpenNebula today, and a lot of these have really large scale as well. So, some of our largest customers scaled over 16 different data centers, hundreds of thousands of cores, millions of VMs in some cases as well. So, we have a really good story about scaling. But today's not ready to go around that. It's to focus on a specific feature we've just released. And the reason we did this, right? So I know many of you on today's webinar will be here because you're looking to move away from VMware, and we've been seeing this as well with our kind of the enterprise edition sales team, and we've seen a huge increase in the inbound opportunities we have because of all the stuff that's happened with VMware over the last 18 months. We've seen product bundle changes, so you're kind of forced down certain paths with VMware, price increases, changes in the partner programs, and even the last 24 hours or so, they've announced the removal of the current Broadcom partner program, which by the end of October, that will be no more. I'm sure it will get recreated in some form, but I think what we've seen in the industry for the last 18 months is just these changes that come up, and it just causes a lot of uncertainty, right? And a lot of the folks we talk to as well really, drill down on the kind of the declining support and services that they've received from VMware over the last kind of few years as well. So this is why we're here, why we've been building such functionality as this. And I think this really started off, very soon after the acquisition by Broadcom happened, really. We immediately jumped on and started creating tools to kind of ease this migration into OpenNebula from VMware. We built migration tools. We really started building up our roadmap to make sure we're focusing on the features and the functionality that people who are looking to move away from VMware want. We've seen all these problems that people looking to move away from VMware have faced, and with that in mind, we've really started positioning OpenNebula as a real replacement with a ton of the features that OpenNebula already had, plus the new stuff that we've been working on recently. One of our kind of strategic customers, Beeks, we had an article in the Register earlier in the year, and I think this was really important because it showed that how OpenNebula has kind of stepped in there, and they've migrated most of their 20,000 VMs over to OpenNebula with some really kind of impressive efficiency stats as well. if you go to our website, we have this pasted all around, and it's very findable online as well. So I want to talk a bit about 2025 so far. So as I mentioned, we've had this huge increase in demand for alternatives from VMware, and I wanted to cover kind of the 6 top requested features that we've seen. This is within kind of like the product and within our from our community, our customers, the prospects we're talking to, and things like that. And I wanted to just cover a couple of them really quickly. So OVA support was a big one from those coming from VMware, and we released this in version 7. In the top right, we have backup via Veeam. So Veeam was the most requested backup solution that we've received so far. We are working on others as well, but Veeam was just the most requested, and we also released this in version 7 as well. In the middle there, live storage migration and storage DRS. So while that isn't in OpenNebula as of today, but it's something we're already working on for our next version, and something we've not gonna say it wasn't considered before, but the focus for folks moving away from VMware to OpenNebula has really ramped up our focus on these enterprise features. The ability to do snapshots on iSCSI data stores. Everyone knows that many KVM platforms have kind of a similar issue where you use LVM to deal with kind of these shared data stores. And OpenNebula does it in a similar way, but we've spent a lot of time kind of building improvements to this so you can do snapshots and thin provisioning and things like that when still using your existing iSCSI or fiber channel data store. SAML authentication, again, it's a really highly requested feature, and because of that, we already have it, in progress for our next maintenance release, we hope. So, if you do have that external directory, you want to use that inside of OpenNebula, you'll be able to do so very soon. And lastly, there in the top right-hand corner, this is what we're all here for today. So the number one feature we actually had from everyone we spoke to recently has been, a DRS alternative. Obviously, VMware's DRS is proprietary, and so it's not like it's something we can just take. But what we've done, and Marco and his team have done, they've built a really good alternative to this that does almost everything VMware's one does plus more. And yeah, so that's basically what today's webinar is about. And just before I hand over to Marco, I'm going to do one quick slide on kind of the other stuff that's coming, right? I talked about the most requested ones, and most of that we've already released in version 7. But as we look towards Q3 and Q4 this year, I want to start talking about the other stuff you'll be seeing coming soon as well. So that's things like Red Hat Enterprise Linux and Alma 10 support, storage DRS and live storage migration, like I mentioned, incremental backups for all the different tools we have. So whether that's our native NetApp integration, our Veeam backup integration, and Ceph and LVM that we've supported for a long time. We're in line with kind of our kind of AI platforms using OpenNebula. We're improving our GPU monitoring capabilities, bringing in SAML support, making some big improvements for LXC. So although it's not most people moving away from VMware opt to use KVM, but LXC still has a thriving community that we're making improvements for. We really hear everyone on the UI UX front as well, and over the next few releases you'll see some drastic UI and UX improvements to make that user experience really solid in OpenNebula. We have a few different tools to manage Kubernetes today, but we want to bring that more kind of first party in OpenNebula, and you'll see that coming towards the end of the year hopefully as well. The way you deal with kind of creating clusters and hosts and all that in OpenNebula will be getting a fresh coat of paint and really improve that workflow as well. And there's a few things like VTPM for Windows, the way we deal with quotas, and much more will be coming as well. But I'm sure we'll be doing a webinar closer to when we're ready to talk about these things in more detail. But with that in mind, I am going to now hand over to Marco to talk about the design principles and architecture of our new DRS platform. So over to you.
Okay, thanks, Jim. Okay, thanks to everyone that is in this webinar. So I'm going to give you some details about the two main components that we have introduced in the 7.0, so the DRS, but also the part of the predictive that we can use together with the predictive AI that we can use also together with the DRS. Okay, so let's first introduce which features we have considered for the DRS, so and what capabilities it gives to you with this release of OpenNebula, the 7.0. So OpenNebula is already a scheduler that is a rank scheduler, is used only for initial placement. So what we have done is to add this new component, the DRS, that allow you not only to do initial placement, so that it can allocate new VM on the host that you have, but also to do this load balancing at cluster level. So you can use the DRS once you define a cluster with several hosts, and you can distribute your workloads, your VM workloads across the different hosts according, for example, to the resource usage, in order to reduce contention, to improve performance of the VM, and this can generate practically migration, right? So the DRS provides you with the recommendation about which are the best migration in order to achieve your balance in terms of workload, or to achieve or to improve the performance of your VMs that run within a cluster. You can have different policy. At the moment, we have this packing policy that you practically tries to minimize the number of hosts that can keep all the VMs that are within a cluster. Or you can use a balance approach that I will explain later also during the demo, all the different options that you can use to balancing VMs across the host. We have another part that we call the predictive DRS, where you can use not only the actual resource usage, so that comes from the monitoring of OpenNebula, but also the forecast. So the prediction about the resource usage, like CPU or memory. Finally, you can use the DRS at different automation levels. So you can do this manually. Practically, that means that you trigger the optimization of the workload within a cluster. And then once the plans are generated, the plans are related to the migration, you can accept or you can not execute them according to what you would like to do, okay? If you would like to perform or not. Then we have also the partial level. That means that plans are created automatically. You can define an interval every time these plans are generated, and then there should be an approving from the user, from the administrator, in order to apply the migration. And finally, we have this full automated level where instead plans are created automatically and are also executed automatically. So these are the features with the capability of the DRS. So let me talk about also what feature we have introduced in the 7.0. Practically, we have enhanced the monitoring system with a predictive analytics. So now we can do prediction about the resource usage. This is both for hosts, so for the infrastructure, but also for the virtual resources, so the virtual machine. So you can have this proactive resource managing because you can identify potential problems issue before they impact the performance of your deployments. And you can use, for example, long-term forecast for doing some capacity planning for your infrastructure. And then this can be used, as I said, with the DRS to improve your VM placement according to the prediction, and not only to the observation, to what is happening now, but what can happen in the future. So we have mainly two features that two forecasts that we have introduced. So one is about the short term. So this is configurable, and for the moment, by default, we have defined 5 minutes. And then we have also a long-term forecast. This is, for example, by default is 30 days. And this is more for capacity planning. Instead, the short term can be used especially for DRS when you have a variable dynamic workloads, and then you have to take a decision every time, and then you want to plan eventual migration. So these are the two main components that we have introduced in the 7.0. Let me explain how we have designed it, we have implemented them. So first of all, let me go to the DRS architecture. So here, practically what we have defined is we have reviewed practically the scheduler framework of OpenNebula. So now we have a scheduler manager that, according to a protocol, practically is going to use some driver that can be plugged in within the scheduler and configured in OpenNebula. So we have a scheduler manager that can call different drivers, and this can implement the different optimization or initial placement. So practically we have two main commands that the scheduler manager will call, is this optimize or place. So for DRS, we have defined a driver that practically can do optimize and place. Place is for the initial placement. The optimize instead is to optimize the workload within a cluster. And then we have the plan manager that instead execute the plan and store the plans. Also, we store the plan. This is in the template of the cluster that where we would like to do this optimization. And the driver is based on, we have implemented this using Python. So we have practically a parser that takes in input all the information about for the optimization, for example, of the workload within a cluster. It takes in input the information about the virtual machine that are running within that cluster, and information about the host pool, information about the monitoring. These are all used for taking decision. Okay, so the parser, what it does is parsing this XML, and then it gives this to an optimizer. We use an integer linear programming approach. So we build a model with all the different constraints. We take into account all the constraints. So we can take into account affinity also. If we have a constraint about affinity, the only thing that actually is not supported, that will be implemented later, is about NUMA nodes, but we take into account everything. So data stores, networks, disks, and all the kind of constraint we have. And then we can take into account the information that comes from the monitoring. As I said before, we have improved, enhanced the monitoring also with the information about the forecast. So this information can be passed to this to the parser and then to the optimizer that can take into account in order to optimize the workload within the cluster. This ILP is based on a library. We use the PULP library, is a Python library for modeling integer linear programming. And by default, these use the CBC solver, but you can plug in other solvers. There are also commercial solvers or other solvers that you can plug in. But by default, we support the CBC that is also distributed by most of the operating systems. And then once we found the solution, this will be given again back to the parser that will produce the XML output. That is an XML that is a plan. So it will contain information about which VM we would like to migrate. And in case also information about other stuff like networks and so on. And then this is given back to the plan manager that will execute or will be visualized to the user that can approve the execution. So this is about the architecture of the DRS and how we have implemented. I will now describe a bit about how we have enhanced the monitoring system of OpenNebula and how we have introduced this prediction. So the point here is that what we have done is we have modified the monitoring probes in OpenNebula in order to write information locally in the host. So for each VM running in the host and for the host itself, the monitorist probe will write data on this database that are local to the host. This allows us to really scale the prediction, because practically predictions are executed by probes that are part of the monitoring system itself. So these are started practically with the monitoring agents. So what is happening here is that these prediction probes that are based on some machine learning models, we are using for the moment a decomposition method for this. But this is highly configurable, because we have written an SDK that allows us also to change and to use also different models. And this depends a lot also on the operating system, which system packages are available, and so on. So we provide by default a method that is based on a decomposition method that just work with some basic Python library like NumPy, CPy that are available on most of the operating systems. So practically, these probes read from this local DB, produce the forecast, and all this information about monitoring and forecast will be sent to the monitoring daemon in the front end, and this will be written then in the OpenNebula database. So we have both monitoring data and forecasting data in the front end. And this can be used then by 1D and by the scheduler manager to provide also information about the resource usage forecast to the DRS. Okay, so this is about the forecast system. Now let me give you an overview of what I'm going to present in the demo. So we will start from a situation where we have different VMs. They are equal VMs on hosts that are distributed, balanced, let's say. So we have 2 VMs per host. Then I'm going to use the DRS in manual mode using the packing policy. So what will happen is that all the VM will move to just one host. And then once I trigger the optimization, then I can apply the plan, and then we will see the migration of the VM. I will show also how you can use the automated mode of the DRS. In this case, practically, we are going to set a balancing policy. So we are going to get to the previous situation, the initial situation, and I will set only 2 migrations. So this allow us to get to the initial situation after several steps, 3 steps in total. And I will show you how the automated mode works. So we can switch now to the demonstration, to the demo. Let me go to... I don't know if you can see now the... Yeah, okay. Now you have... Okay, so here I have defined a cluster. We have 4 hosts. And as I said before, we have 2 VM for each host. Okay, so these VM are the same with 1 CPU, 1 gigabyte of memory, and also the hosts are the same. Let me show also one thing about the VMs. So now in the 7.0, when you click on a VM, you can see the graph here is about not only about the monitoring, but is about the monitoring and the forecast. As you can see, I hope you can see here, it's pretty small, but there is data about forecast and data about the CPU. Here, for example, is 1 minute forecast for the VM. I just generated with some stress the load, and then you can see that the forecast more or less is following the load. Clearly, this kind of techniques depend on the data. Much data you have, more accurate could be the forecast. And so, but you can have clearly some inaccuracy of this method. Depends clearly on the time series, non-linearity, and so on. But this is just to show you how it looks now, the part of the monitoring of the VM. It's not only about CPU usage, but also is about the forecast. So now let's go back to the cluster, and let me go to the OneDRS. Okay, so first of all, what you have to do here is to enable the OneDRS. And when you enable here, you can choose between the policy. So as I said before, we have two different policies. One is balance and the other is packing. And the automation can be full, manual, or partial. Okay, now I'm using the manual with packing, and here you can see the migration threshold. At the moment is unlimited. What that means is that the DRS will try to minimize the number of migration, but can use any number of migration. Okay, so the DRS always try to minimize the number in order not to reduce the cost of migration. And so in case, but you want to limit this, you can put the number here. In case it's unlimited, the DRS try to minimize, but it can use any number of migration. So let me show you first what means manual. So let's accept this. Now the DRS is enabled. As you can see here, we have the configuration option. So we have migration threshold -1, policy packing, and automation manual. Then you have to trigger this by clicking optimize, sorry, okay. And as you can see here, when I click optimize, a plan is generated. So in this case, since we use packing, we can put all the VM in one host. As you can see here, the migration will move different VM on one host. In this case, it's host 4. The hosts are the same, so there is is indifferent which host we are going to choose, but you can see that all migration are related to the same host. Now, this is manual. If you agree on the plan, you just click apply and the migration will start, okay, of the different VMs, in this case, on the host 4. So after the migration, what I expect that only the host 4 will have all the VMs, the other hosts will be empty, because we applied a packing policy. Let me check. This can take some time. Okay, it's already done. So now, as you can see here, we have only one host with all the VM, and the other 3 hosts are empty. Usually packing can, for example, you want to minimize the number of hosts because you would like to reduce power consumption. So you can use packing, and this will allow you to have, or you would like to do some maintenance of the host, packing allow you to do multiple maintenance on different hosts and take the VM on other hosts. Let me go back to so this is for packing and manual. Now let's go back here. Once the plan, as you can see here now, the plan is in done state, so all the migration have been applied. I can delete this plan, and I can update the configuration. So let's now use balance. Now, when you use balance, you have options about which kind of resource you would like to use in order to do this balance. So you have here, for example, 2 related to CPU. Now, CPU is related to the requested CPU, is what you put in your template or when you instantiate your VM. CPU usage instead is the real CPU used by the VM. And then you have memory usage, network, and disk usage. Okay, so for CPU, we have 2. For the moment, I will use the CPU ratio. And then you have this predictive, where you can put this to 100%. What that means is going to use prediction about the resource. So in this case, not the ratio, but if we select CPU usage, we can use, for example, prediction of the CPU usage. And then we can even change the migration. I will put here 2 now. So that means that the DRS every time will try to find a solution that with the maximum number of migration, in this case 2. And I will put now this in full. So this will be done automated. So what I expect here, so we start from a situation where all the VMs are packed. I will allow the DRS to do only 2 migration every time. And so at the end of different steps, I'm going to expect that the VM will return to the initial situation. So let's accept this. When you do this automated, you cannot do anything anymore manual. So you cannot trigger optimization. You cannot do anything else. So here we have the options. So in this case, migration threshold 2, we have balance policy, automation full. In this case, we are using CPU ratio. Okay. So what now I set you have an option in the configuration file of 1D when you can set the interval of the DRS to a certain time. So at the moment, I put this to 60 seconds. So every minute, a new plan is generated. And then, since this is automated, now this is generated. So as you can see here, we are moving these two VM on to other hosts. And since it's automated, this is also applying the migration. Let me go back here to the host. And as you can see here, now the host 4 has 6 VM, and 3 and 2, 1 VM each. So the DRS is distributing the loss. Why can it put only 2 migration? Because we set maximum 2. So in the next cycle of 60 seconds, we are going to have the new migration. Okay, so we have to wait other 60 seconds, and then this. And at the end, this will allow us to have the distribution as it was before, when we started with these VMs that were spread across all different hosts. Let me see if the other one is started now. Should do every 1 minute. Because I wanted to show also another thing. Well, let me see if, okay, now he's applying the next one. And now here you can see that other 2 VM has been moved. In this case, he chose the host 1. So we have this kind of distribution. And then at the next step, all the hosts will have the same number of VM. One thing that you can do also, as I said, you can use the predictive. And usually in this case, what you have to do is to use this value here. So 100% means I use only the forecast, but you can use, for example, part of the forecast and part of the observation. And as you can see here, you have also weights for balancing different resource usage. So for example, you would like not only balance the CPU ratio, but you would like to balance the CPU and memory, okay? So because you would like to I don't know, to equally distribute in terms of both CPU and memory, not only about CPU. So this depends on the different use cases. So we give this possibility in order, for example, to choose between different resource usages. Let me check if everything should be at the same. Yeah, after 3 steps now, clearly for the next step, there will be no other plans because now the situation is balanced. And let me do one thing. Let's see if let's see. I have some loads on the VM. Clearly, I don't know which will be the solution here because oops, sorry. I want to do manual this one. Let me delete this one. But usually when you use a CPU usage, this depends on the load that you have on the different VM. As you can see here, since I generated this, I have some loads, but it's not full load. So VM can be at maximum, some VM minimum. You still have here migration because it tries to balance now the CPU, the real CPU usage, and not only anymore the CPU requested. Okay. And I think that's all for the demo.
Okay, hi guys, I'm back. So now, thanks, Marco. What a great demo! I've been playing around with OneDRS myself, and it's a very cool feature. I do want to say that for sure. But we do have a couple of questions, Marco. Hopefully that's okay. We can go through these quickly. So we did get a few that came in on the sign up form for the webinar. So we had a question first of all around storage DRS, and I know well, it's not something we have right now. I know Marco and his team are already working hard on it because it's, again, a really popular feature of ours. We had a question about prerequisites, Marco. So is there any, it doesn't need shared storage, it doesn't need is there any prerequisites around there that OneDRS needs to
it needs, sorry, Jim, can you repeat?
Perhaps it needs shared storage, or it needs more than 4 hosts in a cluster or something like that. Is there any prerequisites around that?
No, the DRS, in order to work, doesn't need, let's say, specific requirements. Clearly, the only thing we need is to allow migration, right? So it depends if you would like to have live migration that you can set practically. So for example, the DRS can use live migration when you apply the plan. This can be set in your configuration. Clearly, your deployment should support live migration. If you cannot support, you can use just cold migration, and in that case, you don't have to set. So it depends if you set live rescheds in your configuration of 1D. In that case, yes, it can support both live. There are no specific requirements also in terms of functionality of the DRS, because everything now is integrated. Also the monitoring system, we are using OpenNebula monitoring system. Also, we have integrated everything there. So there are no other requirements in order to function.
Gotcha. There was another question. It alludes quite into this, I think. Is it available for all users, or is it Enterprise Edition only? And I think you touched on this at the start, Marco, that as it's kind of a fundamental part of OpenNebula, this is available to all users. So it's not.
Yeah, it's a part of OpenNebula release, and everyone can use it. Also, the forecast we introduced in the 7.0, we are working on it because we found we needed to improve, especially the short term. Yeah, but we are working on that. But at least we have integrated within the OpenNebula, and is available for everyone. Yeah. So.
Awesome. There was a question around how often does the optimizer run, and I think it's we saw that in your last bit of a demo, didn't we? That you had customized it to run more frequently.
So you have these options. It's called a DRS interval in 1D.conf. And you can configure that. By default, I think it's 600 seconds. So it's a time. I put in 60 seconds just to make the live the demo live working. But you can decide about this. Also, the forecast is highly configurable. So you can configure your forecast time, both the short term, the long term. The retention of the database. So there are a lot of, you can look at the documentation of the 7.0. There is all the information about how to configure the DRS and to configure. By the way, also the DRS can be used for initial placement, but you can use the default rank scheduler. By default, OpenNebula use for initial placement, the original one, what was before, and for cluster optimization, the DRS, because it's the only one that at the moment can do this kind of optimization within the cluster.
I think that ties into some of the live questions we've had here as well, and I'll try and paraphrase some of these. It's quite long, but there's one question around using DRS to be more intelligent scheduling related to OneFlow inputs. So, would you want to cover anything related to OneFlow? So, the current scheduler looks at each VM individually versus the collections coming together as a service. So, when we're using multi-VM services.
But we have we deal with the constraint about affinity, and so maybe I think we can extend somehow to OneFlow. At the end, we have a group and of VMs, so somehow it takes into account also if you define some affinity, it takes into account the affinity of the VM. So, for example, if you need some VMs that are affine, so they should be on the same host, right? This is taken already into account by the DRS. You just have to define this kind of affinity between also different types of VM. So you can use VM groups and affinity groups of OpenNebula, and this is already implemented.
Gotcha. I think there's another question around. I think it was on this same. Like as it's used for the initial placement as well. So does the DRS scheduler only take effect if a VM is actually scheduled onto a specific hypervisor? So this is in the placement section during building a VM. I have an issue where VMs with no cluster assigned can run in any cluster. So if a host is in a cluster but a VM on that host is not, will DRS still put that in the plan to migrate?
Sorry, for the optimization within, let's say for the optimization of running VM.
I think what this is talking about is when you don't specifically say you want a VM
for the initial placement. For the initial placement, the DRS can be used, but in this case, the DRS, so the scheduler manager pass all information about pending VM. Okay, so what he will do, the DRS, he will consider globally. It will not be related to any cluster in particular. So it depends if you have some requirements that no, when you would like to schedule this VM, but the DRS doesn't take into account, I mean, is not constrained by anything, but it consider all depending VM. So it will take a global decision here. So could be even better than an heuristic schedule. This depends on the use case. But yes, he can just place where it could be placed.
Okay,
but we distinguish the two situations practically. So the DRS can use or to optimize running VM in a cluster, or to place initial VM, but this is independent from the cluster.
Gotcha. There's another one around, does DRS need shared storage? So it's not a requirement for using OneDRS, but obviously it can really improve the live migrations. When
as I said, if you would like to do live migration, you need live migration requirements, or if it's supported also with not shared storage, the live migration, well, it takes more time, but you can do. So there are no requirements by the DRS. It depends on your deployment, let's say.
Cool.
And especially for migration, because at the end, DRS just gives you no recommendation about migrations of VMs.
Cool. And I think the last question we have time for today was around, I think it's all the different parameters for the balance mode. So one of the factors VMware uses is latency per data store versus the VM's input output load. Is there a plan to also evaluate that as well?
For the moment, what we have is you can use the disk usage, but we can introduce some other metrics. So the point is that for the moment, we are just using some metrics about usage and these kind of things, but doesn't mean that we cannot add other metrics. So if we have metrics that represent, for example, latency, these kind of things, we could use within the objective of the DRS. Okay, so if there is a need to introduce some other, and then you can use even weights. So you would like to evaluate multiple metrics for balancing the load, you can use these weights in order to add multiple metrics to take into consideration by the DRS. Yeah, but at the moment we have just CPU usage, memory, I think networks, and are about usage on IOPS per second.
I think that's the thing, isn't it? It was just a few weeks ago we launched OneDRS in version 7, and this is the first release. So we'll be looking at feedback from our customers and users and community to make future improvements on this as well. So, but we'd love to get, if anyone's trying out OpenNebula version 7, we'd love to get any feedback or anything like that from you guys as well. So please do feel free to reach out to us if you have any questions or additional questions, and any feedback as well will be really useful. But thank you for attending today's webinar, and thank you as well, Marco.
Thank you, Jim, and thank you all. Okay, thanks.
Bye bye.
Bye bye.